everyone, this is me Swala Thakur, and in this video lecture we will discuss about the lattices. So in this session we will discuss about the topics what is lattices, types of lattices, sublattices and some special type of lattices. So without any delay, let's get started. So what is lattices? So basically a coset, a partially ordered set is called a lattices if its every pair should have GLB and LUB. Or another definition of lattices would be every coset is set to the lattice if it is semilattices and mid-lattices and joint semilattices. So, to understand the concept of lattices, three topics you must know before are coset. So, a coset is a partially ordered set in which our relation on set is reflexive, transitive and antisymmetric. And Hasse diagram is used to represent a coset. And the topic supremum and infimum are called LUB and GLB, which we will discuss in next slides. So what is greatest lower bound GLB? GLB is also called infimum, mid, and it is denoted by this inverted V sign, and the operation between the two ordered pairs are called AND. So the greatest lower bound is a greatest element among the elements of lower bound of two ordered pairs. So now what is lower upper bound? So lower upper bound is also called supremum and joint and denoted by this V sign, and the operation between two ordered pairs is called OR. So lowest upper bound is called lowest upper bound is what we can say that a lowest element between the elements of upper bound of two ordered pairs. So now next slide is we do a question on given Hasse diagram. So the question is given Hasse diagram is lattices or not? We have to figure out it is lattices or not. So in this diagram we have two ordered pair 2 and 3. In this ordered pair we have to find the lowest upper bound and greatest lower bound of these two ordered pair. So for 3, 6 and 2. So for upper bound of 2, upper bound of 2 is 2 itself, 6 and 12. Upper bound of 3 is 3 itself, 6 and 12. And upper bound of 6 is 6 itself and 12. To find the least upper bound of these three elements, we have 6, which is the least between these three elements of the intersection of these three elements. Then the 6 is the least upper bound of 2, 6 and 3. And for also we have two ordered pair 2 and 3. So the least upper bound of 2 and 3 is also 6. But what about the lower bound of these two elements 2 and 3? So lower bound of 2 is 2 itself and 1. Lower bound of 3 is 3 itself and 1. So the intersection of these two elements is 1. So 1 is the only element here. That's why the greatest lower bound of these two elements is 1. But in this diagram, we have found that they both have greatest lower bound and upper bound and greatest lower bound. So this particular diagram is lattices. Let's move forward to next question. So the next question is given here that A is a lattice. A is a Hasse diagram. We have to draw here according to this condition that x is less than or equals to y. So according to the condition we have drawn Hasse diagram, and we have to find that this particular Hasse diagram is lattices or not. And the another part of this question is we have to find LUB and GLB of A, which is 2, 3, 6, and B, which is 2, 3. So for lower bound of A, which is 2, 3, 6, we have the lower bound of 2 is 2 itself, lower bound of 3 is 3 itself, and lower bound of 6 is 6 itself, 2 and 3. And the intersection of these three elements is 5, which is not exist. Therefore, the GLB of these three elements is also not exist. These three elements don't have any GLB. And for the element B, which is 2 and 3, we have their lower bound, which is 2 and 3. But the intersection of these two elements is nothing. So there is a 5. And therefore B also not has GLB. Now we forward to the upper bound. So upper bound of 2 is 2 itself, 6, 12, 36 and 24. And the upper bound of 3 is 3 itself, 6, 12, 24 and 36. The upper bound of 6 is 6, 12, 24 and 36. So to find out the LUB, we have to find the intersection of these elements, which is 6, 12, 24 and 36. Now the LUB, which is least element among this element, is 6. So 6 is the LUB of A. And for B, which is 2 and 3, and here are the lower bound of 2, here are the upper bounds of 2, and here are the upper bound of 3. And the intersection of these elements is this 6, 12, 24 and 36. So these LUV of 2 and 3. Therefore, we have seen that in this particular diagram 2 and 3 don't have meet, but and 24 and 36 don't have join. Therefore, this particular Hasse diagram is not a lattice. Next. Now we talk about the joint semilattices and meet semilattices. So what is joint semilattices? If a lattice every pair has a joint, then it is called joint semilattices, and if in a lattices every pair has GLB or meet, then it is called a meet semilattice. You can see in this diagram that 4 and 6 has 12, and 6 and 3 has 6, 4 and 2 has 4, 2 and 6 has 6. So this particular diagram is example of joint semilattices. But we can see here that 2 and 3 has not a meet, therefore this is not a meet semilattices. So and in this diagram 8 and 12 don't have a joint, therefore it is not a meet semilattices, joint semilattices, but they have 4, 4 and 6 has 2, 2 and 3 has 1. So therefore every element has a meet, therefore it is called a meet semilattices. Types of joint semilattices, types of lattices. So first type is distributive lattices. The lattices is said to be a distributive lattices if all ABC are elements of L follow these properties. So these are two properties of distributive law, and every three elements of lattices should follow these properties. So another definition would be a lattice is said to be distributive lattices if every element has at most one complement. So you can see in this diagram, to find out the complement of every element, first you have to discover the maximal and minimal element of the lattices. Here in this diagram, B is maximal and F is minimal. To find out that A is a complement of C, first we have to find out the GLB and LUV. So if GLB is equals to minimal element and LUV is equals to the maximum element, then the particular pairs are complement to each other. So this lattices is the perfect example of distributive lattices. Now we talk about the modular lattices. A modular lattice is said to be when if every three element follow the law of modular law. Here you can see that every three element A or B and C equals to A or B and C. This is an example of modular lattices. So now we talk about the complement lattices. So in which every element should have at least one complement. Now understand one thing, that distributive and complement are different from each other. Now distributive we have to find at most one complement, and complement lattices we have to find at least one complement. So in this diagram you can see that B and C are two incomparable pairs, and when we found that B and C has LUB which is equals to D, and which is also the maximal element of this diagram, and the GLB of B and C is A, which is equals to the minimal element. Therefore this particular lattice is a complement lattice. Next. Now we move forwards to the sublattices. So a sublattice is a non-subset of a lattices where it should follow the operation which is join and meet. Every pair should follow the operation join and meet. Here an example where L is a lattices, and we have to find that L dash is a lattice, sublattices of L is or not. So we have L 1, 2, 3, 5, 6, 10, 13 and 15. So we take the subset of these lattices which is 1, 2, 6 and 3. Here we can see that 2 and 3 has join which is 6, and 2 and 3 has meet which is 1, and 6 and 1 has join which is 6, and 6 and 1 has meet which is 1. So every element has a LUB and GLB. So this particular lattices is a sublattice of this L. Now we move to the last topic of our session, which is special type of lattices. So in a special type of lattices, a complete lattice is a special type of lattices, because in these lattices every subset of the lattices should follow the LUB and GLB, means every subset has LUB and GLB. Therefore we can see in this example, this is a lattice which starts from 0 and ends to 100, but we take a subset from this lattices which is starts from 97 and ends to 100, and here we can see that these four elements has LUB 100 and GLB 97. So they have LUB and GLB. So now we talk about which type of lattices are not a complete lattices. So here is an example which is it starts from 0 and end to infinity, and we take from this we take a subset from these lattices which is x is such that when x is greater than equals to 0. So here the GLB of every element should be 1, but we have not LUB, which goes to infinity. Therefore LUB is not exist. Therefore this particular subset is not a type of is not a complete lattices. Remember one thing, that finite lattices are complete lattices and infinite lattices are not complete lattices. Thank you for watching this video. That's all for today. I hope you liked it and understood the whole concept. Thank you.